This is the first living machine ever made. It is called a Xenobot. They are like machines, but made out of organic components, and they are programmable. They are made out of the cells of the frog Xenopus laevis, an African clawed frog, hence the name Xenobot. Although they don't have stomachs, brains or a nerve system, their cells are alive. But Xenobots only live for about a week. They eat small platelets of yolk that would normally power the embryonic development. But what can those organic bots do? Normally, the movements an organism can make are determined by its DNA. This is because DNA shapes every organism. But this is not true for the Xenobot. Its shape is not determined by its DNA, but by its design. Its shape is designed for it to be able to fulfill certain tasks. The shape is designed in a computer simulation using physics engines. The designers of Xenobots ran an algorithm to find the best form for a specific task. After a design was settled, the team began to form cellular figurines that resemble the design from the algorithm. The Xenobot works like a normal robot, with engines that coordinate movements. But these engines work differently than normal machines. They are made out of living muscle cells, which contract and relax, somewhat like in the body of an animal. The outcome of the muscle contractions depends on the form of the Xenobot. They don't need energy in form of electricity. They also are biodegradable, which means that they will dissolve after the task is complete. They can even heal themselves when they got damaged while still doing their task. In an experiment, they were able to heal themselves after being nearly completely torn apart. This is a huge progress in nanotechnology, and their possible fields of application are huge. Wherever tiny machines are needed, Xenobots can operate. Here are some examples. They can sweep up ocean microplastics into collectible balls, which could then be picked up by ships. They are able to deliver drugs to specific cells in an organism. They do this very reliably, so patients may need a smaller quantity of the drug than if it was simply diffused by the blood in their veins. This means Xenobots can be used to cure cancer much more effectively, because they only attack the mutated cells and not the healthy ones. Xenobots can clean arteries from cholesterol to cure heart diseases as well. But it is still a challenge to make Xenobots work in a human body. Our immune system defends itself against every intruder it doesn't know, so it would try to destroy a Xenobot. For a Xenobot to work in a human body without a reaction by the immune system, the Xenobot needs to be made out of the patient's cells. But as I said before, right now, Xenobots are made out of frog cells, so this is a challenge science has yet to overcome. But there are some other problems as well. However, these problems are of a social and an ethical kind. Like nearly everything humanity creates, also Xenobots can be dangerous. It all depends on their usage. They are programmable, so they can do every physically possible task you design them to do. Even bad things, like terrorist attacks, as a bioweapon. And there are some ethical problems as well. Many open questions still remain. Is a Xenobot a machine, or an organism, or something in between? In a biological context, although the cells are alive, the Xenobot is not a living being. It is more of an organism than a virus, but it is still human-made, and it won't replicate itself. Still, it is also not made of metal or runs on some kind of electric energy, like machines usually do. Currently, the Xenobot is made out of frog embryos, so in order to make a Xenobot out of human cells, we would have to sacrifice an embryo. Plus, Xenobots are handmade, so it takes a while to craft them. Therefore, all their benefits might be far in the future.